Ever wondered how astronomers measure the mind-boggling distances between stars and galaxies? We have miles and kilometers for Earth, but when you look up at the night sky, those units just don't cut it. Today, we're going on a journey through cosmic yardsticks, from our solar system's backyard to the edge of the observable universe. Let's start close to home, in our own solar system. To measure distances here, astronomers use something called the astronomical unit. It's a beautifully simple concept. 1 is the average distance from the Earth to the Sun, which is about 150 million kilometers, or 93 million miles. Using the UNO makes talking about our solar system so much easier. Mars is about 1.5 from the Sun. Jupiter is a little over 5 away. Saturn is at 9.5. See? The numbers are neat, tidy, and easy to compare. The O is the perfect tool for measuring our planetary neighborhood. But what happens when we want to venture beyond our solar system? What if we want to measure the distance to the nearest star? This is where the astronomical unit starts to fall apart. The closest star system to us is Alpha Centauri. If we try to measure its distance in a US, we get a number that's just massive. Alpha Centauri is about 270,000 away. 270,000, that's a huge, clunky number that's hard to visualize. It's like trying to measure the distance from New York to London in inches. You could do it, but why would you want to? The O, so elegant within the solar system, becomes a tiny, inadequate ruler when faced with the immense emptiness between stars. Clearly, astronomers needed a bigger yardstick. They needed a new unit that could handle interstellar distances without turning into a long string of zeros. The inspiration for this new unit came from the fastest thing in the universe, light. Light travels at an incredible speed, about 300,000 kilometers every single second. To put that in perspective, a beam of light could zip around the Earth more than 7 times in the blink of an eye. But even at this blistering pace, the universe is so vast that it still takes a significant amount of time for light to travel from one star to another. And this delay, this travel time, gave astronomers the perfect idea for a new cosmic ruler. And so, the light year was born. Now, the name can be a little confusing. A light year sounds like a measure of time, but it's not. It's a measure of distance. A light year is simply the distance that light travels in 1 year, and that is a very, very long way. It's about 9.5 trillion kilometers, or nearly 6 trillion miles. This new unit completely changes the scale. Remember that clunky number 4, Alpha Centauri. Instead of 270,000 we can now say it's about 4.3 light-years away. Much cleaner, right? Suddenly, the cosmos feels a bit more manageable. Let's look at some other examples to see how useful the light year is. The brilliant star Sirius, the brightest star in our night sky, is about 8.6 light-years away. The heart of our own galaxy, the Milky Way, is around 26,000 light-years from us. And what about our closest major galactic neighbor, the Andromeda Galaxy? That stunning spiral you see in photos is 2.5 million light-years away. These numbers are still huge, of course, but they are far more intuitive than trying to express them in OEs or kilometers. The light year gives us a way to talk about the universe on its own terms. But there's something else that makes the light year so powerful and a little bit poetic. It directly connects distance to time. When we look at a star that is 100 light-years away, the light hitting our eyes today actually left that star 100 years ago. We are literally looking into the past. Every telescope becomes a time machine. The farther we look out into space, the further back in time we see. Astronomy isn't just about mapping space. It's a form of cosmic archaeology. Every photon of light that reaches us is a messenger from a distant past, telling a story of what a star or galaxy was like long ago. So, when you see a picture from the James Webb Space Telescope of a galaxy 13 billion light-years away, it means you're seeing that galaxy as it was 13 billion years ago, not long after the universe itself began. The light from that galaxy has been traveling through space for almost the entire age of the cosmos, long before the Earth or even our Sun existed. This is what makes the light year more than just a unit of measurement. It's a window into cosmic history. Now, for the sake of scientific precision, it's worth mentioning that professional astronomers often use another unit called the parsec. 1 parsec is equal to about 3.26 light-years. The name comes from parallax second, and it's derived directly from an observational technique used to measure the distance to stars. It's a bit more technical, but it links directly to the raw data astronomers collect. So, In scientific papers, you'll often see distances listed in parsecs or kiloparsecs, but for communicating these vast distances to the public, the light year remains the king. Its connection to the speed of light and time makes it far more intuitive for most of us. The evolution from the astronomical unit to the light year really mirrors our own journey of discovery. The O helped us map our home, our solar system, and understand our place among the planets. It gave us a sense of scale for our immediate surroundings. But as our curiosity grew and our technology advanced, we realized our neighborhood was just a tiny corner of a much larger city. The light year was the tool that allowed us to start mapping that city, our galaxy, and even the other cities, the other galaxies, scattered across the universe. Together, these units create a ladder of measurement. The O is for the local steps, and the light year is for the grand interstellar leaps. They remind us that for every scale in the universe, from the distance between planets to the vast expanse between galaxies, our relentless curiosity has found a way to measure, to compare, and to understand. So, the next time you look up at the stars, remember that you're not just seeing points of light. You're seeing distances measured in years of light's journey, and you're looking back into the deep, incredible history of the cosmos. Thanks for joining me on this cosmic journey today. If you enjoyed this and want to explore more wonders of the universe, don't forget to like this video and subscribe to the channel for more space adventures. See you next time.